Howdy everybody in YouTube land. So I went ahead and decided I was just going to go ahead and fix it because it's not really worth putting the time and effort of, completely gutting this and redoing it. And there's a few factors that caused me to make this decision. One is there's just not enough room in here to put a good set of iron, because you need a power transfer. Let's say even if I did single EL84s, I would have to do, a power transformer capable of handling that, which would take a good section of this. Plus, I'd need two output transformers. I can get smaller ones, but they're only good down to like 100 hertz to 15 kilohertz. They're meant for voice applications or AM radio applications. They're not really meant for hi-fi audio. Maybe guitar practice amps could do it, but they're not really meant for hi-fi audio. So there's no way that I know of to do what I want with this small of a chassis. Maybe if this was a mono block and I had another one to complement it, I could probably put a single output transformer and a single power transformer on it and do like a push-pull something another. I don't know, but at that point I'd have to find another one and then just sink more money in it than what it's worth. So I just decided to go ahead and say screw it and repair it and send it along down the road to its next owner, whoever that might be. I just have to figure that out at this point. Anyways, enough with that. Got my bag of parts ready. So I bought some extra parts to fix this. The other thing I need to figure out if I want to do is these tube shields, which they're not even really shields. I mean, they're very, very razor thin. So I could feel the edge, the knife edge, and this will cut the shit out of you if you touch it the right way or the wrong way. And they look tacky. So I'm thinking about just removing those to begin with, because these look tacky. And plus I got one of them that's bent anyways. So I'm just probably going to pull this board out right here and remove those shields. I'll probably do that after I fix this board. The other thing I noticed too is they didn't test bad, but there's these driver transistors here. 2SD 667, and what is it, 2SB 647. Well, instead of keeping those driver transistors, I bought some equivalents, because here's the thing, these drivers have been discontinued for years, or these transistors complementary transistors have been discontinued for years, and so there's the likelihood is strong that those are knockoffs, because this amp is modern. This is a modern amplifier. So yeah, there's no way those are genuine transistors. They haven't been manufactured in years, so they're going to go bye-bye. I'm going to replace them with BD139, BD140s as the driver stage to drive the output transistors. So that should take care of this problem, so that won't happen again. And then I got the parts to replace the bridge rectifier, and I got a fuse and all that fun stuff. So let me get this out of the way first. Actually, no. While this is up here and in my way, I might as well just take these shields off. So let me take the shields off first, and then I will get to this board and start pulling the parts off of it. Actually, the shields are going to have to stay on, because look how they did this piece of shit. There's a screw and a nut that runs all the way through, and it comes all the way through into the board. So see? So I don't have a choice but to leave them on, because it holds this board down. Otherwise, I'd have to buy all new hardware, and at that point, it's just not worth it. So at this venture, I'm just going to tighten everything up and make sure everything's secure, and then just do it that way. So I went ahead and tightened these the best I can. They didn't use any standoffs either. And then so they just spin and spin and spin until they just warp the whole board in. So I snugged them up. There's no such thing as tight on this piece of shit, but it's the best I can do given the circumstances. So that's tight. It's out of the way. I will have to fix this wire when I go to put it back together, because, well, it's broke clean off. So I'm going to go ahead and get this off the table here and get that ready. My desoldering iron warmed up so I can get all of that done. Alrighty then, that's out of the way. I got that warming up. While I had that warming up, I went ahead and unpacked the bag of parts, and that's interesting. I've never seen that on a Mauser package before. They're just glass fuses. For G-Lay. Handle with care. Okay. Got both 41s and 42 transistors, which is interesting because that's where, hold on, what are these? 41C, 42C. That's interesting. So they pack them in loose in a bag like that, but they box them up in that one, which I got a stack of those boxes over here. There's the replacement mic insulators. I went ahead and got all 4 of them. That way I can just go ahead and change them all and not have to worry about it. Got the new bridge rectifier, and there are the BD140s. Where's the 139s? There they are. Those will replace these driver transistors. The drivers, like I said, the drivers did not test shorted. The emitter resistors are not open either, but I'm not taking any chances with those transistors because, as you can tell, I mean, look at that. Nasty. So, matter of fact, that might be why it's reading shorted, because look down there. It's globbed over together. So that explains why that went pop. Alright. Let's go ahead and pull all that off. Oh, the things that make you say, Well, I was in the process of pulling this out, and I've noticed as soon as I went to suck the pin out, it got clogged up, because there's the pin right there. But it's all clean here. So then I realized these are just bodged into place. Someone just tacked them in there. The middle pin wasn't even soldered. It wasn't even touching anything. And then look at this. There's the insulator. Someone let it slide right down there and just, threw it together just like that. The things you find out in the field, this is the real world when it comes to electronics repair. The things you find out in the field, it just never ceases to amaze you. It's just interesting, the things you're going to run across. So, yeah, that'll all be taken care of when I do this the right way. So let's continue on, shall we? One thing to note when you're doing transistor substitutions like this, or any part substitution really, is when you're matching up specs, also you need to match up the pinout. In this case, the base is on the right-hand side with the writing facing you. It's exactly the same with this transistor as well. Sometimes I've seen them reverse. I've seen them go base, collector, emitter, where this one goes base, collector, emitter. I've seen them go emitter, base, collector, or I have seen them go, the other way around. So it's one thing you got to pay attention to when you're installing substitutions inside of the board that these came out of, is the polarity of the transistor. Otherwise, you might blow some more stuff up. So anyways, there's the pile of parts, and that's exactly what happened. Is these pins were just tacked into those pins. It's now that I got all the parts out, now I'm going to go ahead and take the opportunity to inspect any other resistors or any other semiconductors to make sure that they're not blown, which they aren't, but I'm going to double check anyways. Obviously, that's something you should do before you put in your parts order. The other thing I'm going to go ahead and do is clean all this stuff up, get some fresh thermal paste on there, clean up the flux and the burn scorch marks from the rectifier when it exploded, and just generally clean all that up. I also marked the board where they go as a safety precaution, but this silk screen has already got markings where they all go, but some boards don't, and it's just a good idea to take annotations of where things go so you don't put the wrong parts in the wrong spot. Also, there's one thing I forgot to mention. I got the flux cleaned up. I got to get that part cleaned now, and I got the heatsink grease cleaned off. But the one thing I forgot to mention, I went ahead and did both sides, even though the one side was the only one that was reading damaged. I just went ahead and did both anyways. That way I could guarantee that both channels are equal and they both have genuine semiconductors installed. Otherwise, there's just no telling. The other thing now that's got me concerned slightly, and I will have to fix that in some way, shape, or form, but these transistors here, those are your bias transistors, and they're supposed to be mounted to the heatsink so it can get an accurate temperature of the heatsink and adjust the bias accordingly. And it's not. So I don't know what they were thinking there, if they were thinking at all. Anyways, so clean that up. We're going to go ahead and start getting all the new semiconductors installed, and I'll go ahead and show you the after. I got the new transistors installed. I got the new solder paste. I got to straighten out these mica insulators, not solder paste, heatsink thermal compound. I got the screws in there. I made sure the shoulder washers are still in there. The mica insulators are now in their proper place. I went ahead and replaced all 4 of them. I'm going to straighten this one up a little bit, and I'm going to torque these down and solder them in place. I'm going to solder the driver transistors in, and then I'm going to solder in the bridge rectifier. Okay, got all the new parts installed. I bent the drivers over because they were originally bent over. I'm not sure if it was due to clearance issues, but I just went ahead and did it anyways. New bridge rectifier is in there. Everything's all soldered up. So, I guess now it's time to put it in the unit and get ready for a smoke test. Man, this thing was a royal pain to get back together, trying to fit all those wires in and snugging all these controls up. Yeah, it's all crammed under there. Yeah. Not fun trying to figure out a way to get the flashlight in there. So I can kind of see. Yeah, that's why those transistors were bent over. They're kind of in the way of that bottom board there. But anyways, everything's all plugged in. I had to use screw. Yeah, so I think at this juncture, it's time to get that repopulated in, that thing over there. So, well, I've decided to go for broke. I got all the screws in the bottom of it. So now the new fuse is in there. So now I just got to plug it in and hope like hell it doesn't explode. Is it going to work? I don't know. Haven't tested. You're seeing this in real time. No flames. I have no flames. Don't smell anything burning. I heard the speaker protection relay click. So, this thing might actually work. I guess we'll find out. Let me get the speakers plugged into it. Actually, no. I don't want to do that yet. That's a bad idea. Actually, I'll tell you what I want to do. I thought I heard the speaker protection relay engaged, so what I'm going to do is I'm going to pull out the good old handy dandy trusty Fluke multimeter here, and we're going to check the terminals for DC, because that would be bad for a speaker. That's minimal. Minimal. Well, that's certainly good news. So, I guess at this point it's time to get the speakers connected and see what the hell happens. So this segment here, I've got to record from my other phone because I was using my old phone, but I got to use that for the audio testing. Anyways, so of course the speaker jacks are put in every which way. So the wires are kind of coming in here and in here and in here and anyways, so let's go ahead and do the sound test on this. I'm not going to do any music because I don't like screwing around with trying to find royalty free and all that stuff. So I already have it paired up with Bluetooth, so we're going to go ahead and kick it on. Make sure the sound is down. The Bluetooth should come on, and hopefully it pairs up. Looks like it's paired. Let's see. Yeah, of course. Yeah, it's paired. So, See what we get. Wow, it works. There's kind of a double hump there. It's Chinese. But what I found really interesting, let's try something here. The audio came on straight away. If you've noticed that, the audio come on straight away. So what exactly are these tubes doing? Huh. Kind of makes you go, what happens if I pull this tube? Does it go out? Normally you don't do this on a live circuit, but all right. Well, it goes out, so we'll see if that channel comes on. Not really. So it looks like I still have a channel that's out. So yeah, it doesn't do anything. It just, that's it. It's all it does. Alright, let's see. Do I have any other channels? Looks like I have left only. Well, let's see. Like I said, these things are every which way. I do not like how these speaker jacks are done. Let me just see if they'll go in this way for now. I wonder if this was the channel that was dead. See if my speaker's not dead. Nope, speaker's good. So it looks like we still have a dead channel. Why? I don't know. You see how this thing was put together and how difficult it is to troubleshoot. So I took it back apart. This time I took the top off instead of the bottom because it seemed like it'd be much easier to look at, because as you saw earlier, the transformer's bolted straight to the bottom. Another note to make is that transformer's really close to the same size of the heatsink, so that little hump is just for show. Of course it's for show, it's China. Anyways, the top plate is also bent around like this, and the sides are mounted to it. So the problem with that is it's not possible to, just change the top cover and build my own amp. Also, the screws are coming in from the other side. So they put the screws in here. Then after they put the screws in, they filled it in and put this vinyl wrap over it, because there's no opening for the screw. So they filled it in. They puttied it in. So the sides are not even removable. You can't even, they're just there. Okay, so now that that's off, I had to unplug the tube section because, well, I can't open it any other way. But let's just go ahead and turn it on. See what we got. Oh, that's interesting. One of the LEDs works and the other one doesn't. This is the channel that was damaged. So, luckily the channel that wasn't still works. And then this one does not. So I actually, even though I replaced parts, I actually didn't accomplish anything. But in a way, it's kind of expected, because there's probably other damage here that I'm not too sure of. That, I haven't really seen yet. So I'm going to have to go through and start testing all these transistors. Whoa, wait a minute. What is that? There's a hole blown in that resistor to one of the voltage regulators. Let's see, hold on. That one's warm. That one's also warm. Let's see, hold on. What do we got going on here? What? Hold on. I think that's just a mark. No. What the? There's a hole blown in it. But that's the channel that's good. That doesn't make any sense. This channel here is damaged. So I need to figure out what happened. So what I'm looking for are any resistors that may have got a hole blown in it, because these, let me turn that off. When these resistors let go, they become visible like this one is. So if this is the same as this one over here, I don't have a schematic. I'll probably never have a schematic, so I don't know for certain. But if I were to hazard a guess, that's a 22 ohm resistor. That one probably is too. So let's just have a look. So here's what we're going to do. We are going to, once again, grab our handy dandy trusty multimeter. First things first is I'm hoping the chassis is also the main signal ground. At least I'm hoping. Because then I can take this guy, put it here. Which sucks because, guess what? That is, the damn screw is right there, so I can't. Alright, hang on. Okay, so here we go. I got the ground here. Let's go ahead and get our meter on. Turn the power on to the unit. Okay, first things first. Let's check these regulators. So, here on this side, 24 volts coming in. Here we got 12 volts going out. That's good. Okay, let's look at the resistor, the burnt resistor side. We have negative 24 volts coming in. Still got 24 volts coming out of that resistor. Let's check the regulator. What do we have coming out of the regulator? Negative 12 volts. So that resistor is, even though there's a hole blown in it, it's still passing current. I wanted to replace it, but it's still passing current. So I guess what I'm going to have to do now is I'm just going to have to start going through this circuit and then figuring out which part has failed. I'll bring you back when I get to that point. Okay, so here's where we're at. I did some probing around, and what I've discovered is, and you can kind of see it here. You see this little black mark? I thought that was an open trace for a minute, but it's not. This is carbon deposit from this resistor blowing out of its sides. This resistor is wide open. I checked the transistors up here. They're all good. Same over here. Same with everywhere else. This is the only thing that stood out to me. So what I did was I looked at this trace here, and I measured this capacitor, and it's reading 2.8 ohms. So I come over here to the other circuit, and it's like 7.5K or something, which is measuring through, or like 7 meg, something like that. So I think I'm going to remove this resistor, and sometimes heating the, capacitor. These multi-layer ceramic capacitors are a known troublesome spot, especially when it comes to cheap Chinese stuff. They love to short. Now, just simply me heating this capacitor up could alleviate the short. But what I am going to do is I'm going to heat the soldering iron up. I want to move this out of the way to see if it removes the short. If so, I got to measure out what it is by taking this one out of circuit. And then using my LCR meter, which is right there, I can determine what value that is and then replace this one if I've got one similar to it. And I got to find a 7.5K ohm resistor, which I may have some through-hole ones over there. I know I don't have any surface mount stuff, but I should have a through-hole one for testing. I'll do that right quick and see if that fixes this problem. Quite likely, that's probably what caused this thing to blow up, because that, I don't know. I have to have a schematic to know what this part of the circuit is. But if you think if it had anything to do with the output, it wouldn't be way over here. But this LED could be part of the bias circuit, so when the transistor got damaged, it could have taken that out. So as a precaution, I measured this transistor, and it's still good and compares with the one that's over there. So I don't know. We'll see. Oh boy, how much deeper do I want to dig? Well, it wasn't that capacitor. Well, let's keep going. I want to pull the LED out. I'd laugh if the damn LED is shorted. So, sure enough, pulled the LED out. It's shorted. The damn LED shorted and caused all of this. Well, I suppose it's kind of hard to say if it was the LED that caused it or if the output transistors burnt the LED out. It's really hard to say, but really? Seriously? Okie dokie then. Time to go dig up an LED. If I want to change that one, I'll probably want to change both of them. See, the other thing is I got to look at my stash, because if this is used for biasing, like a constant current source for the differential pair or something like that, I don't know the circuit design, so I'm guessing. Since this is a Class AB amplifier, it's probably using that as part of the biasing or constant current source. So that that LED is critical that I use, because that could be anywhere between 1.9 to 2.1 volts drop. So I have to use the same thing, and they're probably using it like a Zener diode. Anyway, so I changed that one, and I gotta go find a 7.1 or 7.2 k ohm resistor, or 7.5 k, or whatever the hell it is. I don't remember anymore. You can see the capacitor standing up where I took it out of the circuit to test it, and it's fine. So, time to go dig up an LED and try all this shit again. Okay, so I have some red and green ones, but I have no yellow ones. Although these indication style LEDs are all about the same voltage drop anyways, which is usually about 1.7 to 2.1 roughly. It varies a little bit. So I'm just going to go ahead and try a red one, because the red and yellow are usually the same. So I'm going to go ahead and try red. I don't have a 7.5k resistor. It doesn't come in a multi-pack, so I'm going to have to add a couple together to get the value that I need, at least for now. So I can just make sure this thing's going to work properly. So I'm going to go ahead and get this LED installed, and then get the resistor patched in there, and then we're going to try this again. Alrighty then, here we go. New LED is in, and my bodge is back in there, and my capacitor's in there, so let's see what the hell happens. Wow. It lit up and didn't explode. Alrighty then, well, let's put the top back on this thing and test it out. Alright, so we're powered back on. I got the top back on. I'm in a channel that was good, so let's turn on our function generator. Turn the volume down. That channel's still good, so let's try the next channel. Hey, we got sound now. Perfect. Both channels are now functional. Let me bring my other speaker online, which these speakers are just over there. And there we go. It works. I think that's going to conclude this video. Unplug all that, because now I just got to put all the screws back in it and put all the knobs on it. So grand total, we now have, let's see, I have to add 2 more parts to the collection. So I have all those. Now I have to add that one. And let's see, where'd it go? Oh, and I have to add that one. So, alright, well, I'm going to, well, let me turn the power off. Figure out what I want to do with this thing. I'm probably going to go ahead and get the correct resistor, although I'm still debating on that. And then we're going to put it together, and that'll be the end of this video. So, thank you for watching. If you have any comments, please feel free to leave them. Yep, that just kicked over because, well, I left it on when I disconnected the Bluetooth. So, If you have any comments, please feel free to leave them. I got to figure out who's going to adopt this unit because I'm probably not going to keep it. I'm either going to put it right back on eBay or do something else with it. I don't know yet. Otherwise, I hope you enjoyed this video and thank you for watching.